Chapter 8, Transformation Notes, Mapping. Okay. Friday. Yeah, in class. Friday. I don't remember. Yeah. Well, get it out. Load it. Add, add some information. There's not a lot, guys. There's only a couple you tries. I've already posted this on Edmodo. It wasn't posted over the weekend, but it's posted this morning. So I have the key information highlighted. If you want to work ahead, I'm going to kind of go over this. We are going to do some guided practice together to make sure we understand the way you might be tested or assessed on transformations. Okay, so basically we're looking at a mapping, some type of movement. If you see the arrow symbol, that means there's some type of movement, some type of change from the pre-image and the image. Your pre-image is your original figure. Okay, your image was a new. We talked about prime, the symbol to represent the image. And order matters. Okay, your order definitely matters. And some of you missed some points on the test because you didn't connect your points in the correct order. If it tells you the shape and it tells you the name, you have to go consecutively. You can do clockwise or counterclockwise, but order is important. So if I tell you that the trapezoid RSTU is mapped to trapezoid ABCD, if I want to find the image of RU, R is the first and the last letter, it maps to the first and the last in the image. So it's going to be A and D. So whatever order they give you, the pre-image and image correlate.
But didn't it also translate?
It depends on the point of rotation. I didn't really give you the point of rotation on here. I know it did a turn. Alright, so the first three transformations are going to be isometry. That means that the size of your pre-image and image will never change. They will be congruent. Alright, so isometry is no size change, maintains congruency, angles are preserved, they are congruent, lengths are preserved, distance is preserved, they all have the same measurements. Similarity transformation is when the is the same but the size is not. So that's when we don't, what would be an example of similarity transformation? Yeah, this would be a similarity transformation. Okay, the size got changed. Okay. All right, so what we have here, basically, sorry, oh, it's not gonna let me do it. Just relax. So
I did like
if it's a translation, it's a slide. So we're trying to figure out which triangle shows the slide of the original ABC. That would be C, G, F. Again, order matters. On your test, when we get into our transformation test, if you put the corresponding parts in the wrong order, you will lose points for that. I know that the B is the right angle because it has the symbol there to indicate that. So I have to make sure I keep that point that corresponds with the right angle in the middle. B is in the middle, A and C. So G is our right angle, so G has to be in the middle. So reflection, another way of thinking of reflection is a flip. So that would be DEC, triangle DEC. Dilation, that's when you stretch or shrink the image. So this would be your example of not being isometry because the size is going to change with dilations. And then rotation is a turn, okay? And we'll talk about points of rotations when we get into that. We'll start off by rotating at the origin and then we rotate different points. All right, questions on this page? Yes?
Read the book, Pete. Did you? Yeah, I did. I did not. Everyone
right, so we should have, if you get the image, you should have 10, comma, negative 7. Okay, so basically, since the rule says x plus 3, whatever the x coordinate is, you're going to add 3 to it. Well, our x coordinate was 7, so you do 7 plus 3. And then the y was minus 4. Our y coordinate was negative 3, so you do negative 3 minus 4. So that's why you should have 10, comma, negative 7. Okay, so find the pre-image. Okay, all of these are the guided practice here. All of these are test-like even each section. Okay, so if this is the pre-image, is this the original or is that the new? We're trying to find the pre-image. So we're trying to find. This is the new. This is your new. So we're trying to find the original. Okay. So on this problem, you have to kind of work backwards. Okay, so think about it like this. If I end up at negative 1, negative 8, we want to know where do I start so that I map to this using the rule x plus 3, y minus 4. So what, if I'm going backwards, right? So if I go back, what do you think my rule is not going to be?
Minus 3.
Yeah, x minus 3, y plus 4. So if I have a negative 1 and I minus 3, that gives me negative 4. And then this would be negative 4. Okay? So you have to work backwards. You have to do the opposite of the rule. All right, verbal translation. If I do on the x-axis plus 3, what direction am I moving?
To the right. Right.
So this would be right plus 3. So this would be right 3 units. And then if I'm on the y, is your vertical, right? That would be down 4. Okay? Right 3, down 4. So if it was x minus 3, what direction would that be?
Left.
Left. Okay. X minus 3 would be to the left. All right. So they want you now, I'm giving you the pre and the image, the original and the new. See if you can see a pattern to come up with the equation that created the point. It went from negative 9 to positive 3. What would you have to do to the x coordinate to make that exist? Yeah, so this would be x plus 12, and then a negative 4 to a positive 8. Again, y plus 12. So we're going to use this rule for this point. If I'm at 2, 3, and I use this rule, what's our image of the point? 14, 15. There we go. Okay? 14, 15. Okay. So we're just taking the same notation. Okay? I've given you the rule. Another way of showing that is using vectors. Okay? All right, so vector. Need you to highlight the definition, get down the key information. Your component form is going to show your horizontal distance. This right here is always your horizontal distance, just like in your order pair, and your vertical distance, your y. They go from parentheses to little brackets. That's pretty much the difference. It means the same thing. It goes from a capital T to no T. Okay? All right, so the example they gave you, and I know your graph is kind of off on the copy, but I have vector CD. C is my initial point, D is my terminal. I will always count, like normally we do rise over run, our slope, but we're going to do the opposite. Instead of changing y over changing x, we're doing change in x. So that's your horizontal distance, then your vertical distance. So the vector component form for CD would just be 2, 3. Okay? All right, so let's see. Could you give me, look at this example 1. What is the initial point? E is the initial point. Okay? E is your initial point. For E, you have to do your horizontal distance. So that would be 4 units. And then you do your vertical distance.
-3.
-3. 3. So now horizontal was 4, vertical was -3. There is your component form. 4 comma -3. Okay. Sorry. On, if I don't give you the graph, guys, I'll give you the order pair. So this is another important example. So to do your horizontal distance, that's your change in your x-coordinates. This would represent the horizontal. And the change in the y-coordinates would be your vertical distance, your vertical change. So I just subtract the x-coordinates, subtract the y-coordinates, and that would be your component form. Okay? So I want you to come up with the component form for this vector. I know your graph is a little off, but here's the point. Here's the point. We first need to do our horizontal and then our vertical. And you're going to put it in your component form. All right, so if you go to the left, what is that? Negative. All right, so what's our component form for negative, -3, and -4? There we go. Okay. All right, so this last example, on this example, we need to do for horizontal, you have to do your change in your x-coordinates. And for vertical, you have to find the change in your y-coordinates. So subtract your x-coordinates, subtract your y-coordinates. And let's come up with the component form for vector LM. Hopefully we got 7-1. 7-1, check your work. Okay. You do 6 minus a -1. And here we do 2 minus 1. Okay.
You don't simplify that like ever?
Simplify it how? What do you mean by that?
Like, you know how, like, for number... Wait, why is number 3, -3, -4?
Because you go, it's the left 3.
Oh, it's going down? Wait, why are you going that way?
This is your arrow. That would be your terminal point.
Oh.
Yeah. Yes. Okay. All right. Last one, last example, and then I'm going to check your 4 answers, 4 questions. First thing, we're going to write this down. If you have 2 reflections over parallel lines, this forms a translation.
Oh. Get it?
Okay? It will form a slide of the preimage.
So let's just compound something.
All right, so we start off, we need to graph the line y equals 5. I'm going to do that in blue. So I go to 5 on the y-axis. That's going to be a horizontal line. That's my y equals 5.
Oh, I did it wrong. Whoops.
And then we also have the line y equals 3. Go to 3 on the y-axis. Graph that horizontal line. All horizontal lines are parallel. So that's why we're doing a reflection over 2 parallel lines. Y equals 3. All right, we're going to start off with graphing our points. We're going to graph the points 310. So that's my A. 712. That's my B. And 710. That's my C. I'm going to connect those. All right, so we have triangle ABC. They want us to find the final image over 2 reflections. Okay? Am I off? 310. Yeah, 712. Okay, so reflections, your line of reflection is a line of symmetry. It has equal distance apart. Okay? So if I'm starting with the blue line, I look at, see how many units I'm away from that line. 1, 2, 3, 4, 5. Do you see that? So it has to be the same distance below it. If I'm 5 units above, I got to be 5 units below. 1, 2, 3, 4, 5. There is my A prime. It is at the order pair 3, 0. I'm going to do the same thing for B and C. Okay? So I'm going to start with the C because I know it's on the same line as A. It has the same unit. So that's 5. I go 5 down. That would be 7. Make sure I'm lined up. Yeah. So our C prime was 7, 0. And what's the B prime? -2, right? It's slowed up on me. -2, right? Did I get that one? The B prime? I gotta stop this. Yeah. Because it's the second. So how far is A prime from the line of reflection? 3 units, right? 1, 2, 3. So I'm just gonna go 3 units above. There's my A double prime. So that order pair is gonna be 3, 6. And then what's the order pair for the C double prime? Count. Physically count if you have to. You should probably see a pattern. This one, C should be 7, 6. And then what's the B gonna end up being?
7, 4. Right? Because it's just going up 6.
Can I borrow this?
7 what?
7, 6. I mean 7, 4.
7,
8. But it's
7, 8.
negative. No, never mind. Never mind. No, never mind.
Okay. All right. So the pre-image, our original to our last image. If I compare the first to the last, this was just a translation. It just basically slid down. Okay. So whenever you reflect over parallel lines, that becomes a translation. I just what did I do?
What happened? The world is ending.
Okay.
Bro,
There.
I'm
Yeah.
mad that the world didn't end in 2620. I really thought it was going to end.
This one right here. I counted how far it was to the red line, and then I did the same count above. So like this was 3 units away, so I did 3 units up.
It's close, but I think the world started. At least I pushed it.
I went. This was. Yeah, 5.
He's like, why am I not dead?
Okay, let's check. You try. For each of the following lines, stop talking, please. For each of the following lines, L and M are parallel. Okay. Determine if figure 3 is a translation image of figure 1. So compare 3 and 1 together. Here is 1. Here is 3. The 2 lines are parallel. Would that be a translation? A slide?
Yes.
Yes. This first one is yes.
But why?
Why? Because L is parallel to M.
That's it.
And you have a double reflection. Those 2 things have to happen. The lines have to be parallel, and you have to reflect them twice. All right, what about 6? Comparing 1 to 3. Would that be a translation?
No.
No, this is a no.
Because it flipped.
Well, if I...
Figure 3 is a reflection of figure 1.
2 and 3 are reflections, but 1 and 2 are not. You have to have a double reflection. Okay? All right, so, oops. What happened? All right, number 7. Look at figure 1 and figure 3. Would that be a translation?
Okay.
Yeah, this one is yes. last one, figure 3 and figure 1. Yep, it's a translation. You have two reflections. That was reflected and then reflected again over parallel lines. Yeah. One is reflected to two, like it, because it's, you see how one kind of intersects it. So this part goes here, that part goes there to make that line, and then these two lines are reflected off. This is going to be reflected off of there between the line and
The erasable highlighter.
okay.